Hello everyone. Today we're going to continue on with our conversation about extrema. Remember, extrema is just plural for extreme. And today we're going to talk about absolute extrema, so absolute minimums and absolute maximums. And to find the absolute min and the absolute max, we're going to be using something called the closed interval test to determine our absolute mins and max on a graph. Okay, we're going to start off by looking at this graph here. So go ahead and sketch that in your notebook. And with the idea of absolute max, okay, is that it's the absolutely the most high point on the graph. And in order to find an absolute max or an absolute min, we really have to have a closed interval. So that means that we have to be working between between a minimum and a maximum on our graph. So in this case here, our minimum value would be A because we have an endpoint, and our maximum value B would be our other endpoint. All right, so looking at this graph, the absolute highest point that we see, what I would say would be right here. And so this one would be called our absolute maximum. Okay? Of course, we have another maximum within our graph. That would be this point right here, but that would be our relative maximum. Okay? And remember, just to review from last time, our relative maximum is only relative when it's the bigger than any point to the left or to the right. So in order to be a relative maximum, you have to have points to the left and points to the right in order to determine that. So whereas an absolute max here does not have to have points to the left or to the right. It just has to be the highest point within the interval that's given. Okay, so now looking at that graph, where would you say the absolute minimum would be? So I would say that the absolute minimum would be the very lowest point, and that would be right here, absolute minimum. Okay, so in this case, our relative min also became the absolute min. Okay, so we have one relative max, one absolute min, and then one absolute max. This point here, this B, is not a relative min, and it's not an absolute min, it's just an endpoint, because I do not have any points to the right of it, and so it can't be a relative, and it's certainly not the lowest point on the graph. Okay, so we have here the definition for absolute minimum and maximum values on a closed interval. I want to make sure that you get this in your notebook, copy it down word for word. It's really important, and it's something that the AP really likes to ask these questions, and we're going to come back to this again and again throughout the year. It says if f of x is continuous, so we know what continuous means. That's a big calculus word. It means that there's no holes, no breaks. It means that you do not have to pick your pen up as you are moving through the graph. No vertical asymptotes. So if f of x is continuous on the closed interval a to b, notice a and b are included, then f of x must have an absolute maximum value and an absolute minimum value. So it must have, okay? It is absolutely 100% true that as long as you have a continuous function on a closed interval, there must be an absolute min and an absolute max on that interval. So if I have, for example, okay, a graph that looks like this, what this is saying is, and it's closed interval, meaning it has endpoints, okay? This is saying that there must be an absolute min and an absolute max. So looking at this, where would the absolute lowest point be? Well, I would say it would be right here, and that would be the absolute min. Okay, where would the absolute highest point be? And that would be right here, and that would be my absolute max. So I have this closed interval between A and B, and I have an absolute minimum and an absolute max. Okay, I just want to show you one other one that sometimes throws students off, so I just want to make sure that we kind of talk about it for a second. If I have the graph of this line, again on the closed interval from A to B, and we'll say that that line has a height of 5. Okay? It says on this definition of absolute min and absolute max that it must have, so this is a function that is continuous from A to B, and it says that it must have an absolute max and an absolute min. So I want you to kind of take a look at this and say, well, what is my absolute max? Well, here my absolute max is equal to 5. And also my absolute min is also equal to 5. So that one kind of throws students off sometimes. So I just wanted to, it looks like a very simple example, but you have to understand that it must have an absolute max and an absolute min. It just happens that in this example, they are both the same value. Okay, so we're going to take a couple, look at a couple examples. This one says, find the absolute extrema on the interval -2 to 5. So this interval is really important. It tells us where on the graph I'm allowed to look. So here I'm looking at -2, so I want to find the point on the graph that's associated with x of -2, and that's my endpoint, is what it's telling me. That's the only, I only want to start looking there. So all of this stuff, it's not important to me. It's not in the interval that I am looking. And then up to 5. So I want to look at the x value of 5 and again find where that intersects, and then everything to the right of that I want to get rid of. So I am only looking at the black curve that is remaining. All right, so now it's saying what's the absolute maximum? So I want to look at this and say, where is the absolute highest point? And if I look at this, I would say that my absolute highest point occurs 2 different places. I would say I have an absolute maximum here and here. Now, you want to be careful because what you want to understand is that the absolute maximum is the height. Okay, so maximum, when they're asking that, that is the height of the function at that point. And so I would say that my absolute maximum here would be 4. But then it occurs at 2 different places. It occurs at x equals -1 and x equals 5. So the maximum is 4 at x equals -1 and x equals 5. All right, now what about the absolute minimum? Well, again, I would look and say, where is my absolute lowest point? And I would say that would occur right here. And so that is at -4. Okay, so the absolute minimum is a height of -4, and it's at x equals 3. Okay, so we're going to go ahead and work through several examples where we're asked to algebraically find the absolute extrema of a function over a given interval. And I want to make sure that you go ahead and get this closed interval test down in your notebook. Okay, this is the process that we're going to go through every time we're asked to find an absolute extrema. Okay, so when you hear absolute extrema, you want to think closed interval test. When you hear relative extrema, or intervals of increase or decrease, relative min, relative max, like we did in the last couple videos, that's when you want to find the critical values, but that's when you're going to set up a number line test. So although they both begin with the same process, they end differently and they communicate different things to us. So please make sure that you differentiate that in your mind, and that should help as we move through these. All right, so the first thing is to go ahead and find those critical values. So we're going to do that the exact same way as we have. All right, we're going to take the derivative of the function. So in this case, f prime of x is going to equal to, it's going to be 2x to the third minus 8x. All right, and we're going to go ahead and set that, it's polynomial, we're going to set that equal to 0 to find our 0, so 2x to the third minus 8x. All right, I'm going to factor out a 2x, and I'd be left with x squared minus 4. And so if I set each of those factors equal to 0, I'll have x equals 0, and I'll have x equals plus or minus 2. All right, so those are my critical values. Now, the next thing we're going to do is set up that table to test it into the original function. Okay, that's another key thing. We're not testing back into the derivative like we did last time. We are determining, see, the whole idea here is to determine the absolute maximum, the absolute minimum. So we want the absolute max and absolute min of the original function. So I need to know what is the height of the function at these different x values and determine which one of them is the highest and which one is the smallest. Okay, so we're going to go ahead and set up this table. All right, now you have 2 different headings. All right, this is going to be your x value. Those are your inputs. Those are the places where they will occur. Okay, f of x, that's what the maximum is. That is the actual height of the graph. So remember, this is the height. This is where okay? This is the height, what is the actual maximum, and this is where it is. Okay, so under your x's, you want to go ahead. Keep in mind your interval. So what you want to do is start by looking at what is the closed interval, because remember, your absolute min and max can be one of the endpoints or one of your critical values. So you need to start by including your kind of bracket off what is the furthest to the left and the furthest to the right you can go with your x values. So we're going to start off with that -3, and then we could go up to a 1. All right, so that's kind of our bracket. Now we're going to look at our critical values, and we can only use the ones that are included in that interval. So is 0 included in that interval? Yes, I would definitely say it is. So I'm going to go ahead and put that in my table under my x's. Okay, is +2 included in this interval? Well, I would say no. +2 does not fit between -3 and 1, so I'm not going to include it. It would just be a waste of my time. But -2 sure does, so I'm going to go ahead and put that in. Okay, so those are the values that I'm going to go ahead and test. And remember, where does it say to test them? Back into the original. I want to know what I want to know what the height is of the function at these different x values. All right, so this is going to take a little bit of head algebra. Okay, I'm going to put these values in. So I'm going to just kind of start with the easy one. So I'm going to start with 0. So 1/2 times 0 to the 4th minus 4 times 0 squared would be 0. So that's an easy one. All right, I'll do the 1. So that would be 1/2 times 1 to the 4th is just 1 minus 4 times 1. All right, so that would be 1/2 minus, let's see, that'd be 8/2. So that's going to be -7/2. All right, let's try the -2. So I got 1/2 times -2 to the 4th is +16 minus 4 times -2 squared. -2 squared is 4, so 4 times 4. So 1/2 of 16 is 8, minus 16 is going to be -8. All right, and then let's go ahead and do that -3. So I'm going to have 1/2 times -3 to the 4th is 81, minus 4 times -3 squared is 9. So let's see, 81/2 minus 36, which I'll just go ahead and double that. That would be 72/2. So 81 minus 72 is 9/2. Okay. Okay, so now that I have all these values in my table, I'm ready to make my conclusion. I'm ready to say what is the absolute largest and the absolute smallest value from those tables. So if I'm looking at this, I would say that absolutely the smallest value here would be -8. So I would say my absolute minimum is equal to -8 at x equals -2. And I would say that my absolute maximum, so the largest value would be 9/2, so is 9/2, and that's at x equals -3. Okay, so let's take a look at our second example. I actually want you to go right ahead and just pause the video right now. Go through that process. I feel like this is very similar to the last one, so go ahead and find your critical values. See if you can set up your table and test the values in. Make sure that you keep in mind the interval that we have here, and see if you can make some conclusions. Okay, so let's take a look at what you have and compare it with what I have here. Okay, so first of all, check to make sure that your critical values, that you ended up with the same that I did, that this is the derivative. You set that equal to 0. I had to factor out a 12x squared. So I ended up with critical values of x equals 0 and x equals 1. All right, the next step for absolute extrema is to set up your f of x table. Okay, and in the x column, I want to make sure to include both values from my closed interval. So there's the -1 and the 2. And then I make sure that my critical values fall within those. So they both did this time, so I included both of them in my table. Then I'm going to go ahead and plug those into my original function. Okay, so I'm going to plug those in and see what I get. And so you can see here, this was 3 times negative 1 to the fourth, which negative to even, it makes it positive, so this is just positive 3. And then minus 4 times negative 1 to the third, which is really negative 4 times negative 1, so positive 4. So that's where the 7 came from. The 0 is super easy, right? 0 minus the 0, so that's 0. 1 should have also been pretty easy. 3 times 1 is just 3, minus 4 times 1 is 4, so 3 minus 4 is negative 1. And then the work for the 2 is put right here. All right, so once I have those, I am ready to go ahead and make my conclusion. Once again, I'm looking for the absolute maximum and the absolute minimum. Okay, so I would be able to say that my absolute minimum, my absolute lowest y value here is negative 1 at x equals 1. And I would be able to say that my absolute maximum is 16 at x equals 2. Okay, this next one is actually pretty basic, but I wanted to get it in there just to show you something that happens at the end here. So we're going to go ahead and take the derivative. G prime of x is just 2x, and so 0 equals 2x, so x would be 0. Okay, that's your critical value. So we're going to go ahead and set up our table, always x and f of x. Put our two endpoints in there as negative 3 and 3, and there's only one value, and that 0 does fit right in the middle of it. So we're going to go ahead and put that in. All right, and so in this case, I'm going to go ahead and plug those back into the original. So negative 3 squared, if I go back into this original, negative 3 squared is just 9. 0 squared is 0. 3 squared is 9. And so I just wanted to do this because I wanted you to see that there are some times when you have the same exact absolute maximum, and that's okay. We would still say, making our conclusions here, we would still say that we have an absolute max of, or at, positive 9, and that is at x equals, and you would be able to say positive and negative 3. Okay, so the maximum, there's only one maximum, but it happens to occur at two different x values. And then our absolute minimum of 0 at x equals 0. Okay, so not to fear, we now have a more challenging one. Didn't want to bore you for too long. So this time we have h of x equals x minus 2 sine x, and we're on the closed interval 0 to pi. So once again, we're going to go ahead and take the derivative of the function. So that would be 1 minus the derivative of 2 sine x. 2 is a constant. Copy that down. The derivative of sine is cosine x. All right. So we're going to go ahead and set that equal to 0. So what happens? Whoops. What happens there? Well, I'm going to subtract, well, actually, I'm just going to add the 2 cos x over. So I'd have 2 cosine x equals 1. Divide by 2, cos x equals 1/2. Okay, so if cosine of x is equal to 1/2. So now I need to figure out what x values that works for. And really, I want to keep in mind my closed interval from 0 to pi. So if I think about my unit circle points, I'm looking for which point has an x value of 1/2. And so hopefully I know that that's this point right here. Okay, root 3 over 2. And so what value is that? Well, that's your pi over 3. So that's an x of pi over 3. Or some of you I know are saying 60 degrees right now. Okay, so but because I'm between 0 and pi, I want to be talking pi over 3. All right, so that is my only critical value for which cosine of x is equal to positive 1/2, because I know the other place where cosine of x is equal to a positive value would be in the fourth quadrant, and the fourth quadrant doesn't fit within my closed interval of 0 to pi. So that's the only one I need to name. All right, so now I'm ready to go ahead and set up my table with x and f of x labeled at the top. Okay, so I have 0. I'm going to have that pi over 3 and pi. All right, now remember I'm testing those back into the original. All right, so the first one would be, well, I'm going to test in a 0. So I'd have 0 minus 2 sine of 0. Okay, well, sine of 0 is what? Think about your sine curve. Sine of 0 looks like what? 0. So 0 minus 0 is just 0. Okay, pi over 3. Well, I already have the point for pi over 3. So it would be pi over 3 minus 2 sine pi over 3. Okay, so this is pi over 3 minus 2 times, what's the sine of pi over 3? Well, I'd say it's root 3 over 2. And then the 2's are going to cancel out. So I just end up with actually pi over 3 minus the square root of 3. Okay? All right, and then the next one is pi, so I should be able to plug that in. So I would have pi minus 2 sine of pi. All right, well, sine of pi, going back to my graph over here, pi I know is right here, and so again I see that the sine of pi is 0, and so 2 times 0 is 0, so this is just equal to pi. All right, now comparing those, you might get a little bit nervous comparing, obviously the 0, we know what that is, okay, but pi over 3 minus radical 3, and then pi. Well, you should know that, of course, pi is 3.14 approximately, okay, so we know that value. All right, so here you can tell if you have 3.14 divided by 3, well, right away it's already smaller than pi. And then if you go ahead and take that and subtract away radical 3, you know that you are definitely going to be smaller than pi. So I would say for sure that pi is my absolute maximum. Okay, so I can make that conclusion. I can say that my absolute max has an absolute max of pi at x equals pi. All right, now which of these is the minimum? Well, the question is, does this pi over 3 minus radical 3, does it dip lower than 0? Is it a negative value? All right, well, you just got to kind of reason through and think this through. Pi we know is 3.14 divided by 3. Well, 3.14 divided by 3 is going to be very close to 1 point something very small, okay? And so if I took and subtracted radical 3, well, radical 3 is about 1.7, and so if I subtract 1 point something like 1.0, 1.1 and subtract away radical 3, which is 1.7, that is definitely going to dip into the negatives. And so for sure, this is my absolute minimum. So my absolute min of pi over 3 minus radical 3 at x equals pi over 3. Okay, the next example we have is an absolute value function, and hopefully you remember what we are supposed to do in order to find the critical values for absolute value functions. Hopefully you're saying to yourself, I need to sketch that, because that's exactly what we need to do. Okay, so if we want to find the critical values for an absolute value function, we want to go ahead and graph that. So I want to look inside this, okay, what does the minus 3 tell me? Hopefully you realize that that tells you you're going to be moving it to the right 3 places. And so I know that this is going to be right here is where the vertex is. It is a positive absolute value, and so we know it's going to be facing up. All right, so we have a graph that looks like this. And actually, I'm only going now from 0, so right here, okay, to 5. So 3, 4, 5, so I'm going to stop right here, okay? And so this is just as much as I want to look at. Okay, now the only thing I care about for right now is really my critical values. And so the critical values are where the derivative is equal to 0 or where the derivative is undefined. So hopefully you remember, because you have that elbow, that you have that comes to a point, you know that that is undefined at that place. And where is that value undefined? I would say that the critical value, my critical value, is at x equals 3. Okay, so now I'm going to go ahead and set up that table. And you might say, well, I can just figure it out from the graph. No, in calculus, we need to have this table to justify, okay, our answer. And yes, we're not really using the derivative at all. We're going to go ahead and put in our values, 0. We're going to put in our 3 and our 5. And we're just plugging it into the original. Okay, oops, this should be an h of x. I probably did that earlier on a different one as well. Okay, so if I go ahead and plug in the 0, I have the absolute value of 0 minus 3, which is the absolute value of negative 3, which is 3. Okay, the absolute value of 3 minus 3 would be 0. The absolute value of 5 minus 3 would be 2. And so I have those values, and so I should be able to now make my conclusions, and I can say that I have an absolute maximum of 3 at x equals 0, and I have an absolute minimum of 0 at x equals 3. Okay, the last one we're going to take a look at is this rational function here. So let's go ahead and get started. All right, so I would take the derivative f prime of x is equal to, so we're going to use the quotient rule clearly. We'll have low d high, so the top is the chain rule as well. So we're going to have 2x minus 1. It would be to the first times the derivative of the inside would be times 2. Okay, minus, so that was low d high minus high, which would be 2x minus 1 squared. D low would just be times 1. All right, all over x plus 5 quantity squared. All right, so let's clean up that top. All right, so here I'm going to just kind of over top of this, I would have 2 times 2 would be 4. So these, I'm talking about these 2's. So 4 times the 2x minus 1 would be 8x minus 4. So that binomial, I'm multiplying times the x plus 5. So I'd have here 8x squared plus 40x for the middle minus 4x would be plus 36x and then minus 20. Okay, now I'm going to go ahead and I'm going to FOIL out this 2x minus 1 squared right above it. So I'd have 4x squared minus, let's see here, minus 4x and then plus 1. But I am subtracting that whole thing, so it's going to be minus 4x squared plus 4x minus 1. All over x plus 5 squared. All right, so cleaning up the top again, I'd end up with 4x squared, let's see here, plus 40x, and minus 21, okay, over x plus 5 squared. Okay, so that is our derivative. It's a real ugly one. All right, but we're going to go through and follow the rules. What do we do? Well, we have to set our numerator equal to 0 and our denominator equal to 0. So we have to set that 4x squared plus 40x minus 21 equal to 0. And that's for our 0. And then we also have to set the x plus 5 squared equal to 0, and that's for our undefined. This one's definitely, the x plus 5 squared is definitely the easier one, and we just get x equals negative 5. Okay, my numerator though, that's pretty ugly. I'm going to go ahead and try to factor that, and I'm just going to use my guess and check method and erase as I go. So if you don't have a pencil, you might want to kind of wait or process through, pause it, and see if maybe you can challenge yourself and factor it on your own first. Okay, so the first ones I'm going to go ahead and try are 4x and x. I know that my first two numbers have to multiply together to give 4x squared, and then my last two numbers have to multiply here to give me 21. So I'll try 21 and 1. So I'm going to test the outer. 4x times 1 is 4x. 21 times x is 21x. They do not subtract to 40, and so I'm going to go ahead and erase those and try again. Okay, so now I'll have, again, let's try the 4x and the x, but instead I'd have 1 and 21. Well, that one's a no right away because I have 84 on the out and 1 on the in, so that's not going to work. Okay, so I know other factors of 21 would of course be 3 and 7 or 7 and 3. So kind of test those out. All right, the 4 times the 7 is 28 and 3. Nope, those don't work. 4 times 3 is 12 and 7. Nope, those don't work. So I'm just processing through different options, okay? So I kind of went through all of my different 4x and x1. So now the only other way to multiply to 4x squared would be 2x and 2x. Okay? And so if I have 2x and 2x, again, I can start with 1 and 21. And so outer here would be 42, and inner is 2. Ooh, I feel like I'm onto something. Okay? So outer is 42, inner is 2. That definitely does subtract to the 40. Now I need it to subtract to a positive 40, so that means I need the 42 to be positive and the 2 to be negative. Okay, so I have figured out my factors. So now I'm ready to go ahead and t-chart, and I get x equals 1/2 and x equals negative 21/2. Okay, so I have those 3 critical values. I have 1/2, negative 21/2, and negative 5. Okay, so I want to go ahead and test those into my original function. So hold on, let me get that. All right, so my original function was 2x minus 1 squared over x plus 5. All right, and again, my interval that I had to work within was from negative 1 to 2, I believe. Yep. Okay, so I have to look at those critical values and decide which ones are even going to fit within that interval. Okay, so I have x and I have f of x. And so I would say that between negative 1 and 2, really the only one that's going to fit is positive 1/2. Definitely negative 21/2 is way too small, and so is negative 5. So of the 3 critical values, I'm only testing one into my original function. Okay, so I'm going to go ahead and test in my values starting with the negative 1. So 2 times negative 1 is negative 2, minus 1 is negative 3, squared is 9, over negative 1 plus 5 is 4. All right, 1/2. 2 times 1/2 is 1, minus 1 is 0, 0 squared is 0, over, well, 0 divided by anything, just make sure it's not 0 on the bottom. Nope, it's 1/2 plus 5, and so we just get an answer of 0 there. All right, and then the last one here is 2 times 2 is 4, minus 1 is 3, 3 squared is 9 again, over, though 2 plus 5 is 7. Okay, so those are my values. If I now go ahead and make my conclusions, I would definitely say that the absolute minimum, I have an absolute minimum of 0 at x equals 1/2. And then I have an absolute max. Well, I have to compare 9/4 and 9/7, and hopefully we would agree that 9/4 would be bigger than 9/7. And so we would say an absolute maximum of 9/4 at x equals negative 1. And there we have it. So the big thing that I want to make sure you take away tonight is that when you are finding the absolute min and absolute max, you're working through one of these tables. Whereas the relative min and relative max, you are working through a number line test. All right, have a good night, and I will see you tomorrow.